Semiconductor. There are three types of materials used in electronic components. Electrical conductors are materials that allow electricity to flow through them easily. Electrical insulators are materials that prevent electrical flow. Semiconductor materials exhibit both conducting and insulating properties. The way in which the material is connected to a power supply determines whether it will conduct an electrical current or prevent it from flowing. A useful way to visualize the difference between conductors, insulators and semiconductors is to plot the available energies for electrons in the materials. Atoms of crystalline solids are closely packed as in crystal lattice, so that their energy levels are closely distributed as energy bands. Energy bands of crystalline solids are made up of the upper conduction band occupied by conduction electrons that are free to move between atoms as electric current. The lower valence band occupied by valence electrons that are tightly bound to their atoms and are not free to move about. In some metals, the conduction band and the valence band may overlap. Thus, the conduction band is occupied by many conduction electrons, causing these metals to become good conductors of electricity. In insulators, the conduction band and the valence band are separated by a band gap called the forbidden gap. For an insulating material, the valence band is completely filled with electrons, which are tightly bound to the atoms, but the conduction band is empty. The two energy bands are separated by a very wide forbidden gap. Therefore, the electrons are unable to gain enough energy to jump from the valence band to the conduction band. In semiconductor, the conduction band and the valence band are also separated by a forbidden gap. For a semiconductor material, the forbidden gap is narrower compared to the insulating material. This enables some electrons with enough energy to jump from the valence band to the conduction band easily. At very low temperatures, the semiconductor behaves like an insulator, since there is no free electron in the conduction band. At higher temperatures, electrons excited by heat energy can gain enough energy to jump from the valence band to the conduction band. When this happens, the electron leave holes in the valence band. These holes behave like positive charge carriers, and can also move freely. When a potential difference is connected across a semiconductor, the holes and electrons move in opposite directions. Thus, both charge carriers contribute to the current that flows. As temperature rises, the electric conductivity of the semiconductor increases, caused by a larger number of electrons being excited into the conduction band, leaving a larger number of holes in the valence band. Thank you for taking time to watch this.